Hello everyone, welcome back to the maths. So in this video, we are going to continue on where we left off regarding how to solve a quadratic equation. This material is based on the IGCSE AS and A-Level Pure Maths 1, but it is also open to any students who are currently studying quadratics in any curriculum. Previously, we talked about how to solve a quadratic equation with factorization method, and now we are going to talk about how to solve it with the method called completing the square. Completing the square actually means we need to rewrite the quadratic expression using only one occurrence of the variable x. Because usually we write it as x squared and x, but in this case, we want to write it with x only. And the method has a much broader use, especially for quadratic equations that cannot be solved by factorization. Let's try to get on with the examples. So let's say that I have this quadratic expression, x squared minus 4x plus 15. And first, we want to focus on how we can change this expression. So we want to change it into the form of d times x plus h squared plus k. So it's going to be a bit different than the one we learned before. So first, we need to find the d. D is going to be the coefficient of the x squared, in which you can see it's going to be 1. After that, we should try to find the h. So how can we find the h? First, we need to divide the middle term by 2. Yeah, we need to divide the coefficient of the x by 2 to find h. So in this case, we know that h is going to be negative 2, and we can try to write it in the form of d times x plus h squared plus k. So it's going to be x minus 2 squared plus k, and now we just need to find the k. So to find the k, we need to expand this first. So let's try to expand it. It's going to be x squared minus 4x plus 4 plus k. Now remember that we only need to rewrite the original expression. So the part 4 plus k should be equal to 15 because we want to make it the same as our initial expression. Okay, so what is k such that 4 plus k is equal to 15? K should be 11. So now we can try to write the complete expression, which is x minus 2 squared plus 11. That's how we do it. Now note, we need to remember that the aim is to rewrite the equation. So we should get the same expression if we were to expand it. Okay? So now let's try to get on to the next example, x squared plus 6x minus 12. Again, we are going to change this into the similar expression of d times x plus h squared plus k, and we have to find d first. D is going to be a 1, and then we need to find h by dividing this middle coefficient by 2. So we get x plus 3 squared plus k, and then we need to expand this, so we get x squared plus 6x plus 9 plus k. Now remember that we only rewrite the expression, so it has to be the same thing. So we need to find k such that 9 plus k is equal to negative 12. And what is k? K should be negative 21. So now we can try to write it as x plus 3 squared minus 21. We only need to rewrite the expression, so we should get the same thing if we were to expand it. Okay, so let's try to get on with the next example. This one is going to be a bit different since you see that the coefficient of the x squared is going to be a 2. So the procedure to do this is that first we need to take out the coefficient of the x squared. So we need to take out the 2. When we take out the 2, it's going to be 2 times x squared plus 3x minus 6. And from this, we now know that the d is going to be equal to 2. You can also say that d is 2 because it is the coefficient of the x squared. Now, to solve the expression inside the bracket, we can try to complete the square like we did in the previous examples. So we need to find h. We divide the middle term by 2. So we have 2 times x plus 3 over 2 squared plus k. And now we need to expand this. So we got 2x squared plus 6x plus 2 times 9 over 4 plus k. And again, the last part should be equal to minus 12. So 9 over 2 plus k should be equal to minus 12. And this gives us k equals to minus 33 over 2. So after getting k, we can try to rewrite the expression such as follows. So this is the more difficult examples because the h is actually a fraction, but the method to solve it, it's the same. So now we are going to go to the next example, and in this case, the coefficient of x squared is going to be a negative. But this doesn't pose any problem because we can just do the same thing. We can take out the negative sign, so it's going to be minus bracket x squared minus 8x minus 1, and then we just have to complete the square for the expression in the bracket. So we know that first, d is equal to negative 1, and then we need to find h. So minus 8 divided by 2. So this gives us minus bracket x minus 4 squared plus k. And now we need to expand this in order to find the expression. Now remember that minus 16 plus k should be equal to 1. So we need to find k, and k should be 17. So now the complete expression should be minus x minus 4 squared plus 17. Okay, now next example, very similar to the one before, we need to take out the minus 3. So it becomes x squared minus 2x minus 3. And we know that d is a negative 3. And then we can try to complete the square just like what we did before. So we divide by 2 to find h. And it's going to be minus 3 times x minus 1 squared plus k. We expand this. And then we got that k such that minus 3 plus k is equal to 9, k should be 12. So the expression should be like this. Okay, so after we learn how to complete the square, now how can we find the root of this equation? So remember that for the left side, we have changed it into this expression, x minus 2 squared plus 11 equals to 0. So how can we find the root? First, we need to simplify this. So we need to move the constant, the lone number, into the right side, and then we need to take the square root of it. If we take the square root, it's going to be x minus 2 equals plus or minus square root of minus 11. When we are taking the square root, remember to also add the plus minus sign. Plus minus sign means that there are two answers that can satisfy this: positive square root of minus 11 or negative square root of minus 11. And after that, we can try to move the minus 2 to the right side. So we have x is equal to 2 plus or minus square root of minus 11. Now remember that if you have a negative root, this is going to be an imaginary root because you cannot actually find the result of square root of minus 11. That's why it's called imaginary. It's not real. We should try to rewrite this. So in mathematics, we know that square root of negative a should be written as I times the square root of a. So what is I? I is going to be the symbol for square root of negative 1. So square root of negative 1 times square root of a. We can rewrite this expression to be 2 plus or minus I times square root of 11. So these are the exercises that I prepared for you guys. I hope that you can try to do it so that you can be more familiar in completing the square. And I've also added 2 numbers of word problems so that you can try to apply this to the word problems. Okay, so that's it for this video. So in this video, we learn how to solve a quadratic equation using completing the square method. And in the next video, we are going to learn how to solve it with the quadratic formula. Please leave a comment if you have anything that you want to ask, and don't forget to leave a like and subscribe. So I'll see you on the next video. Bye-bye.